In the previous video, we learned about multiplying complex numbers, and the next logical step would seem to be division of complex numbers. And actually, there is no formal division operation which is defined for complex numbers. And so instead what we do is we look at a method for simplifying the quotient of two complex numbers. And to do that, we need a concept known as the complex conjugate. And this is an easy concept. The complex conjugate is basically another complex number with the same real part and the opposite imaginary part as the original number. So for example, we need to find the complex conjugate of each of these complex numbers. 5 minus j2. We leave the real part the same. We take the opposite of the imaginary part. We get 5 minus j2. That's all there is to that. Now we have negative 3 minus j5. Keep the real part the same. Change the sign of the imaginary part. We get negative 3 plus j5. That's all there is to that. Okay, now we have just the imaginary number j6. Well, you can think of j6 as a complex number with real part 0. So if we keep that real part the same, change the sign of the imaginary part, then the complex conjugate is going to be a negative j6. And of course we can think about any real number as a complex number with imaginary part 0. And if we keep the real part of a real number the same, of course it doesn't change. So the complex conjugate of 4 is just 4. Now, why is this concept defined? Well, it turns out that the product of any number and its complex conjugate is real. Okay, so let's see that with an example. Multiply any complex number by its conjugate, the answer is going to be real. Let's see now that that's true for this example. 2 plus j3 times 2 minus j3. It's a complex number and its conjugate. So foiling this out, we have 2 times 2 is 4. And then we have plus 2 times a negative j3, that's O. And then we have j3 times 2, that's I. And then we have j3 times a negative j3, that's L. So there's 4, there's a negative j6, there's positive j6, and there's a negative j squared 9. Okay, well, we have a positive j6 and a negative j6, so that means the imaginary part's going to drop out, and we replace the j squared with negative 1. That gives us 4 plus 9. The answer is 13. Okay, now we're ready to simplify the quotient of two complex numbers. And the way this is done is by multiplying numerator and denominator of the quotient by the complex conjugate of the denominator. Okay, so for example, we have the quotient 5 plus j4 divided by 2 plus j3. So first, we need to get the complex conjugate of the denominator. 5 plus j4 divided by 2 plus j3. The complex conjugate of that denominator is 2 minus j3. So I'm going to multiply numerator and denominator 2 minus j3. Now, why are we doing this? Well, because we want to make this denominator real. And the way to make the denominator real is to multiply by the complex conjugate. Now, we just looked actually in the previous example, and we saw that 2 plus j3 times 2 minus j3 is just 13. So this means we only have one multiplication to do. 5 plus j4 times 2 minus j3. And when we do that, we get 10, 5 times 2, and then 5 times j3, and j4 times 2, and j4 times j3 with a negative sign. Okay, so that'll give us 10 minus j15, and then plus j8, and minus j squared 12. And by now you know that we need to replace the j squared with negative 1, and so this becomes a positive 12, and the answer is 22 minus j7. Okay, so that's the multiplication that we need to do to get our numerator. So this is 22 minus j7. The denominator is 13, as we saw from the previous example. Okay, so there it is. And it is worked out here in the notes for you.